Number 17. Find the mass of each of the following. So we're still using the ideal gas law. So PV is equal to nRT. This time we're solving for mass. Well, here's the problem. None of these 5 terms represents mass. So our best bet is to identify what we're given. Okay, we are given volume, so that's accounted for. We're given pressure, that's accounted for, and temperature, that's accounted for. Now we always know what the ideal gas constant is as long as we understand what units we're supposed to use. So the only quantity I have in PivNert in the ideal gas law to solve for is N. But you might be thinking, but Johnson, that's the number of moles. Well, that's right. You're exactly right. If we solve for the number of moles, we can use the molar mass of whatever species we're talking about, right? Notice that the question is actually pointing out what the species is, so I can calculate the molar mass. We can use the molar mass of that species to convert number of moles into the mass. All right, so this is going to be a two-parter. Each part is pretty darn simple. Right? For each of the ideal gas laws that we've done so far on these prep problems, we've done some simple algebraic rearrangements and some plug and chugs. Pretty darn simple. This time we're adding that simple plug and chug to a conversion. But it's a simple conversion, right? You can't get any easier than a molar mass. So here we go. I want to solve for N. I want to solve for the number of moles. And I already did that for number 16, right? Get that in the camera. So here is the equation I'm going to be using. I'll make it nice and simple. And then at the end, I will convert using the molar mass. Now, I want to, let's see, when you're doing the type of problem like this, feel free to calculate the molar mass of each of these species beforehand. I mean, I'm going to do it as I go, but if you want to use your periodic table out of the way so that you can just do your conversions and your rearrangements at once, kind of like stay in that flow, feel free. That's a strategy too. Maybe 32.0 grams per mole is going to be about 17.04 grams per mole, and this one is going to be, what's that, 32 plus 32, about 64.01 grams per mole. So I already know what these molar masses are, just because I have some of these numbers kind of memorized by this point. But make sure that you don't sleep on just cranking these out. You can crank them out before you start, you can crank them out at the end. Either way, just make sure that you don't sleep on getting those molar masses. So we are solving for N. That is PV over RT. And our pressure, where's our pressure? 1.75 atmospheres times volume, which is 5.60, all over my ideal gas constant, 0.821 liters atmospheres over moles Kelvin, multiplied by my temperature, which is 250 K. Okay, notice that atmospheres cancels with atmospheres, liters cancels with liters, and then kelvins cancels with kelvins, so the only unit I have left is the number of moles, which is useful because I need to solve for moles, and then I can use the molar mass to convert into mass, which is what the question is actually asking me to do. So, time to calculate. Let's get my numerator taken care of. 1.75 times 5, so what's that, 2? Let's see, where's my delete button? Yeah, 5.6 all over 0.0821 times 250, and I come up with again 3 sig figs, 0.477 moles, and I'm going to convert out of moles into grams, and I know that for every 1 mole there are 32.0 grams because it's O2, right, the mass of 2 oxygen atoms, and I am left to multiply by that molar mass. All right, 3 sig figs. That 7 tells me to round that 2 up to a 3, so I'm going to report 15.3 grams for A. All right, just a two-parter, just rearranging Pivner and then doing a simple molar mass conversion. Looking down at B, I noticed that I have degrees Celsius again. Add 273, so that's 300 K. N is equal to PV over RT. My pressure is 0.921 atmospheres. My volume is 3.50 liters. Ideal gas constant is the same as it is constant. Temperature, I want that in kelvins. And so I'll be solving for some sort of number of moles here. My numerator, 0.921 times 3.5. That's all going to be over a denominator, 0.0821 multiplied by 300. And so that's my number of moles. I'm going to stick with this for 3 sig figs, so 0.131. And I'm going to convert out of that into grams using the molar mass of ammonia. Now, if you look at your periodic table, you'll see the mass of nitrogen is 14.01. There are 3 hydrogens, each at 1.01. And so that's going to be 17.04 per 1 mole. Moles cancel, and my last calculation is ready. Times 17.04. 3 sig figs, 2.23 grams. My final answer. Now looking at C, I see that, again, that's milliliters. I need actual liters because this ideal gas constant is using liters. And so I'm going to just move this decimal 1, 2, 3 places. So that'll be liters. And I'm going to change that degrees Celsius into kelvins. So negative 53. That was 53, right? Yeah. Negative 53 plus 273. End up with 2. And now I can continue on using the same strategy that I have been. N is equal to PV over RT. Where's my pressure? 0.822 atmospheres. Volume is 0.125 liters. That way I can keep using my ideal gas constant of 0.0821 liter atmospheres per mole Kelvin. Then my temperature was 220 K, solving for some number of moles. My numerator, 0.822 multiplied by 0.125. That's all going to be over 0.0821. Oh, you know what? I always like to have my parentheses up. It's kind of my thing. Times 220. End up with 5.69, right? With 3 sig figs. But I'm going to be needing one more step. I need to convert out of moles and into grams. And that way moles cancel. This is SO2. SO2. This is going to be 64.01 grams for every 1 mole. And so I'm going for 3 sig fig, 0.364. Grams.